All right, on our stats, we're starting chapter 6, dealing with the binomial probability distribution and related topics to that. 6.1, we're going to concentrate on random variables, and there's two different types, and our probability distributions. Okay, two very straight concepts in this particular section. So first thing we're going to do is we're going to distinguish between, let me go here, we're going to distinguish between discrete and continuous random variables. We're going to look at a graph, which is going to be a histogram, and we're going to compute two things. We're going to compute mu and sigma. We need to remember what those are, okay? We're not going to worry about the linear function yet. But this mu right here is a mean, but a mean for a what? Population. Phenomenal. And this is the standard deviation for a population as well, okay? So remember, x bar and s were the mean and standard deviation of a sample, okay? And then mu and sigma for a population, okay? So now random variables. For our purposes, we say that a statistical experiment or observation is any process by which measurements can be obtained. For instance, you may count the number of eggs in a robin's nest or measure daily rainfall in inches. Those are two important ones because they actually are discrete and continuous, which we're going to get to in a second. It is common practice to use the letter X to represent the quantitative result of an experiment or observation. So we're going to call that X a variable. Here is the X. A quantitative, numerical, variable X is a random variable if the value that X takes on in a given experiment or observation is a chance or random outcome. Here are your two. A discrete variable, everyone, a discrete random variable can take only a finite number of values or a countable number of values. For example, if I said, during period A at Archbishop McCarthy, how many students are in each classroom? That is a discrete variable. So I can go and I can count them, and you're not going to get 25.5 students, are you, in a class? No, they're going to be a set number. That is a discrete variable. A continuous variable, on the other hand, can take on any of the countless number of values in a line interval, okay? So we'll take a look at a couple of those. See, in a sense, discrete's going to be this whole number, and a continuous, you can throw all these decimals out. Like the distance an ant travels in a day. You see, if you could go inches, that's fine. It could go 58 inches. It can go, 153 feet, but it can also go decimal. It can go 113.28 inches, yes? So as soon as you start getting these decimals is when it turns into a continuous. So a couple of examples from the book, all right, that they gave us were as follows. Let's look at this first one. It says, let's figure out if this is discrete or continuous. Measure the time it takes a student selected at random to register for the fall term. Do you guys think that's continuous or discrete? Is it going to take every single person the exact same amount of time to do it? It may take you 53 seconds. It may take somebody 2 hours, 14 minutes, and 11 seconds. That's going to be what? Continuous. Time, and the measurement of time is going to be continuous. Okay, I'm not writing these down, and you guys need to listen. Count the number of bad checks drawn at a bank on a day selected at random. What do you think? Discrete or continuous? Discrete. You can count them. You can walk in the bank. How many canceled checks you guys have? 23? Done. Discrete. How about this one? Measure the amount of gasoline needed to drive your car 200 miles. That's continuous. Somebody in my last class was like, well, I'm going 200 miles, so it's going to be the same every single time. No. What if you get on 95 and there's a traffic jam and your car's running? Are you going to use the same amount of gas than if you drove straight there? No. If you go straight 200 miles up to Orlando, it's different than if you go 200 miles through town, down through Miami, down to Key West, back. You see what I'm saying? Because you stop, go, start. It's continuous. You're going to get a different answer for each. Sometimes it may take 23.28 gallons. Sometimes it may 21.54326 gallons. You don't know. And finally, the last one, if I said, pick a random sample of 50 registered voters in a district and find the number who voted in the last election. Definitely what? Discrete. It's not going to be 23.2 of the 50 vote. No, 23 voted, or whatever it may be. So let's break it down. In most cases, we will consider a discrete random variable will be the result of a count. The number of students in a stats class is a discrete random variable such as 15, 25, 50, 250 are all possible. However, 25.5 are not possible to be in a classroom. That's discrete. Most of the continuous random variables we will see will occur as a result of a measurement on a continuous scale. For example, the air pressure in an automobile tire represents a continuous random variable. The air pressure could, in theory, take on any value from 0 pounds per square inch to the tire bursting. All right, look, 20.126 or 20.12678. They can all be one of the answers. That is continuous. Now, ladies and gentlemen, probability distribution of a discrete random variable. A probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. Our features: the probability distribution has a probability assigned to each distinct value, and the sum must be 1. Here's our example of the day. This example is very big. Please know how to do it. Dr. Mendoza developed a test to measure boredom tolerance. He administered it to 20,000 adults, ages 25 to 35. The possible scores were 0, 1, 2, 3, 4, 5, and 6, with 6 indicating the highest tolerance for boredom. The test results are shown to the right here. So 0, you get bored really, really quick. 6, you're pretty tolerant. You can kind of cope with a lot of things. So this guy right here says there were 1,400 out of the 20,000 that had that 0 tolerance level. There were 2,600 that were 1, 3,600 with, did everyone see how the data was collected? Beautiful. I bet you $23 that if I take 1,400 and divide it by 20,000, what they did here is they took that data and turned them into probabilities. Ladies and gentlemen, I will get 0.07. Respectively the whole way down. Here are all of your probabilities of each individual event, i.e., they add up to give you what? 1. This is the beginning of a probability distribution and us finding mu and sigma. Probability of 5 is 0.8, or means plus. Probability of 6 is 0.02. So the probability of getting a 5 or a 6 on this tolerance scale is 0.10. They're mutually exclusive, which means you're going to use the regular addition principle. These probability assignments must make up the probability distribution. Notice that the scores are mutually exclusive. Nobody can get 2 scores. So therefore, you can ask a simple question: what is the probability of getting a 5 or a 6? Well, guess what? And we proved that they draw it up to give you 1. I probably won't have you draw, but there's a visual distribution for you, and I told you it was going to be a histogram. All right, most likely you will not have to draw one. There's that example, 5 or 6. There's the 1.10. Okay, so probability distribution can be thought as a relative frequency based on a very large n. It has a mean and a standard deviation. If we're referring to the probability distribution of a population, then we use the Greek letters mu for mean and sigma for standard deviation. Population, mu, and sigma. And here are your 2 formulas for the day. Let's see if I can get this a little bit bigger. And here we go. Your mean, ladies and gentlemen, mu, is found by taking the sum of all the x's times the probability of those x's. The 0.01, the 0.00, those things. The standard deviation obviously is the square root of the variance. Well, the variance is the sum of each x minus mu squares times each p of x, each individual probability. Now, you've done many a charts in this class, and this is going to be another chart, and it's not very bad. So let's take a look at an example. The example for the day says this: are we influenced to buy a product by looking at an ad on TV, an infomercial? The National Infomercial Marketing Association determined the number of times buyers of a product had watched a TV infomercial before purchasing the product. And here are the results. You guys all sat there before and watched TV. What's the one with the flex tape? The guy with the flex tape and spraying his boat. You know what I'm talking about? Flex Seal. Okay? It took me a really long time of watching this guy before I bought it. And I bought it and I love it. Okay? So, what does this say? You're watching TV and you see an infomercial for whatever product. 27% of the time people buy it by seeing it one time. Seeing it 2 times, it increases to 31%. 3 times, you're probably getting bored and you're like, I don't want to see this anymore. Notice it drops. 4 times, you're probably really upset, so it drops to 9%. And then notice this guy jumps up. I assume 5 asterisk. I assume asterisk means 5 and more. You see it 6 times or 7 times or 8 times. And notice it kind of pops back up because they're like, wait a second, maybe since this infomercial has been on so long and they're spending this money on the infomercial, maybe this product is actually something I should buy. Okay? So there's our data for this example. We are going to construct distribution. Okay? So we can treat all of these percentages and turn them into, forgot to say, everyone, that mean that you're finding, the mu and the standard deviation sigma, that mean has another special name called an expected value. All right, so the mean of a population, another name is called an expected value. That 2.54 was our expected value in this distribution. Decimals. So here is the chart. This is the one that you're going to have to be able to do. Okay. Unfortunately, everything is already here, so I'm going to kind of piece it together for you. Please understand what we have. This is given to you. Those are the number of times you watch an infomercial. And this is given to you. Those are your 2 givens. I don't need to give you anything else. I need to give you the x, which is our discrete variable, and the probability distribution of each of those discrete variables. And here we go. The first thing I'm going to ask you to do is multiply each of them together. So you're going to do 1 times 0.27 and get 0.27. 2 times 0.31 and get 0.62. Yes? Beautiful. That's where all of these numbers come from. Super straightforward. Then I'm going to ask you to compute the mean. This is the mean. The mean is the sum of each of these guys right here. So if you pull out your calculator and you hit plus, you get 2.54. That, ladies and gentlemen, is your population mean. So what is it saying? Well, on an average, somebody watches 2.54 infomercials. And now to continue with our distribution. In order for us to eventually find our population standard deviation, we're going to do this next. We're going to take each individual value, each discrete, and subtract that mean you got. So 1 minus 2.54 is negative 1.54. 2 minus the 2.54 is negative 0.54, and so on. Then we're going to have to square everything. Why do we have to square? Because you can't have negative values. You're looking at the distance we are away from the mean. Remember, standard deviation is the spread about the mean. So we have to square each of these numbers, and that's where these come from. And then we're going to have to take each of those squares times each individual probability again. So you're going to come back all the way here to column 2, take the 027 times the 2372, and that's what you get. And then the 031 times that, and that's what you get, and so on and so forth. And then everybody, you're going to add each of these numbers together and get this guy right here. Does anybody tell me the name of this guy? We're one step away from standard deviation. What is the name of the step that's one step away from before you take the square root of him? Starts with a V. Variance. That's the variance. And then, ladies and gentlemen, yeah, these are all in your notes. Just to pull them in. What's the matter? Okay. We are going to take his square root to find our standard deviation, 1.37. Okay. So away from that 2.54, it's 1.37. So basically on average, 1.37 times you see a commercial you may buy. All right, and that's everything that you need to know for 6.1. Right? Random variable, continuous or discrete, you have to know the difference between the two. And then when I give you discrete data and their probabilities to be able to complete a chart that will enable you to find the mean of a population, which is also called the expected value, and sigma, the standard deviation of a population. Okay, probability distribution is what we're dealing with. All right, that's the end of 6.1.